Okay, Leslie, Kamani, Jose, check this out. So what we're working on right now, finding factor pairs. In 4th grade, you need to be able to find all factor pairs for numbers from 1 to 100. Remember, a factor pair are two numbers that you can multiply together to get a total. So, for example, in this equation, 2 and 12 are factors. All right? And we can say that they're factors of 24. We can say 2 and 12 are factors of 24. And remember, we call this a multiple. 24 is a multiple of 2, and 24 is a multiple of 12, right? And, we also call this a product. Anytime we multiply the answer to that, it's called a product. So what we're working on today in math is finding factor pairs of a number. So one of the best ways to find factor pairs is to know your multiplication facts. So for example, if we want to find all the factor pairs of 24, just think about the multiplication facts that you know. Well, I know 1 times 24 equals 24. I know 2 times 12. And I know 3 times 8 and 4 times 6. And that's all of them. Those are all the factor pairs of 24. And if you want to just list all the factors like this, you could do that just to have them all laid out in order. And then I like to show the connection because every factor goes with a partner. Whoops, I forgot 24. Like that. So that's a good strategy for finding factor pairs of a number. We just found all the factors of 24. Or let's say we have a number like 35. Well, I know 1 times 5 is 35. And I know, what? No, it's not, dummy. 1 times 35 is 35. And 5 times 7 is 35. And that's it. Those are all the factors. It has a lot fewer factors than 24, doesn't it? So the factors of 35 are just 1, 5, 7, and 35. It has only 4 factors. All right? So there's other strategies to think about too. There's other strategies. You could try, let's say we have the number 28. Well, we know 1 times 28, right, is a factor. But then we're trying to find others. Here's the thing to think about. 28 is even, isn't it? This is an even number. Well, you know what's a factor of all even numbers? 2. 2 is a factor of everything that's even. And now, do we know our multiplication facts? 2 times what equals 28? You might not know that exactly. So you might have to think some other factors. You might have to skip count by 2 till we get to 28. 4, 6, 8, 10. That's 5 groups. You know what? Can we just skip and go to 20? 20, that's 10 groups of 2, right? So now we've got 11 groups of 2, 12 groups of 2, 13 groups of 2, 14 groups of 2. So this is 14 groups of 2 right here. So that means 2 times 14 equals 28, right? And then I also know another multiplication fact, 7 times 4. Right? Good. And those are the factors of 28. But what if you said like, well, Mr. Jensen, I think 3 is a factor. Isn't 3 a factor of 28? Well, how could you test that? There's all kinds of ways to test. Well, first of all, I think, does 3 times anything that you can think of equal 28? Nothing comes to mind for me. I can't think of any multiplication fact of 3 times anything that equals 28. All right? But you could test it further. What if we skip count by 3s? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Oh, look at that. We went from 27 to 30. We did not land on 28 when we skip count by 3s. So therefore, 3 is not a factor of 28. All right? So there's different strategies. You can use skip counting. You can check to see, is it odd or even? You can check to see, your multiplication facts. These are all ways of finding factor pairs. All right. These are all ways of finding factor pairs. And I don't want to make this video too long. All right. So I'm going to add in one more thing. Prime numbers and composite numbers. Now, prime numbers have only two factors. Only have two factors. So a number like 2. 2 is prime because its only factors are 1 and 2. That's it. 17 is prime because its only factors are 1 and 17. It doesn't have any other factors. And if you're thinking, oh, it's only kind of small numbers that are prime, that's not true. You can get some really big numbers. Like I'm, off the top of my head, I know that 61 is prime. It doesn't have any other factors besides 1 and 61. So those are prime numbers, numbers that have only two factors. Then there's composite numbers. Well, you can probably guess what a composite number is. I'll say that. They have more than two factors. They have more than two factors. So that's what composite numbers are. For example, the number 10. 10 is composite because its factors are 10 times 1 and 2 times 5. That's 1, 2, 3, 4 factors. That's more than 2. All right? So composite numbers have more than two factors. Prime numbers have only two factors. The number 1, it's not either of them. It is neither prime nor composite because it only has one factor. Its only factor is 1. 1 times 1 is 1. That's only one factor. So it's not either one of them. All right. There's a lot more to learn about this, but I'll just start you with that. All right. There is an assignment in Seesaw. Do your best on it. Just take a shot. It might be kind of rough, but it's just your first attempt at this. All right. So give it a try in Seesaw.